Hello to all of you. And so what we're going to be doing is we're just going to be going through a basic tutorial on how to use Fusion 360. Now, we're going to be going through the sketch tool, we're going to be going through some of the modify things, and we're going to be going through how to use constructions and how to import different files, such as the files we got here. Now, first off, we're going to go through the sketch tool, how to build a basic thing. Now, let's say we want to build a simple basic connector with 3 millimeters. What we're going to want to do is we're just going to want to use some of the basic tools, rectangle tool, diameter circle tool, and we're just going to want to make different things. So let's say we just want to make a 25 by 25 triangle. And so we're just going to want to do that and then extrude it. Now it's going to want to be small, so let's say 10 millimeter height. And now what we're going to want to do is we're going to want to make it hollow. Here, let me pull up an example of one of the things we did. And let's say that right now, all we are trying to make is this right here. This little thing. And so what we're going to want to do is we have this triangle, but we're going to want to make it hollow. And to do so, a simple way is just to pick the top, and let's say we want to have 2 millimeter thick walls. In reality, that's not that thick, and we normally would want a much more sturdy piece. But for this tutorial, let's just say that this is our measurement. And so we're going to want to take that, and we're just going to want to make 2 crossing lines. That way we can have a little triangle in the center here. We'll hit finish sketch, and we can extrude this downward. Now, the one issue with doing this is when you extrude it, it'll just extrude right through. But the way we prevent doing that is by using the two-side one. That way, we can control both sides, control the amount we extrude up and down. That way, we can say we don't want to extrude on the top here, but rather on the inside. And now that we've done that, you can see we have a perfectly hollow area. And so from here, we have this connector, but we don't have any holes that the screws would go into like we do here. And so to prevent that, we can just make them. And so we're going to want to divide this into 3. Let's say it's 21. And so to divide that into 3, we know 21 divided by 3 is just 7. So let's go 7 millimeters and 7 millimeters. This way we can make these little holes right at the 7 mark. And let's say we just want to use 3 millimeter screws. In reality, we would not want to make 3 millimeter holes for 3 millimeter screws, because if we were to 3D print this part or use some other tool to make this part, it wouldn't be 100% accurate. We'd want some tolerances to make sure that it can fit right through without having to do any extra work. Now, to do that, we'd normally just say 3.1 millimeter hole. Just give it some room and space to where it can thoroughly make the part. But for this, it's just a simple tutorial. We're just going to say it's 3 millimeters. So we're going to want to do that with both the parts here. So 3 millimeters. There we go. And we have 2 perfectly even holes. And we're going to want to finish the sketch, and then we're going to want to extrude them. To do that, you just select the extrude tool. You select the sides you want to extrude, then you extrude it out backward. That way you have 2 little holes here. Now we're going to want to do the same thing for this side, in which case we can just do the exact same thing. Create the line, divide it by 3. 7 and 7. Now we can just take this tool, 3 millimeters, and 3 millimeters. Finish sketch, and we're just going to extrude it. Now we have a very, very basic connector. But as you can see here, it's yellow. And so the reason we do this is so we can tell what parts are which. Because when 3D printing or when making a part out of steel, they have certain textures and different things that allow you to tell which parts are where. And we use that very frequently to tell what a robot actually looks like. Because let's say you didn't add colors or you didn't add materials or physical materials to any type of part. You'd just be sitting there with a blob of gray. It would be hard to tell which part's which. And you can tell that it looks much more pleasant and it's easier to tell what you're working with when you have a fully thought out design. Like here, I'll pull up the last year robot that we worked with. Lift. We also were not very organized, so do not judge our system. We're going to pull this up. It might take a while to load. But once it does, we can see that we use color coding to make sure that everything is perfectly lined up, to make sure it all fits together and that we can tell what we're looking at. Because the entire point of CAD is just to make sure that everything works, to make sure that know where everything goes. It's basically you build a blueprint at the same time as you test out the robot before actually spending all the money on it. And as you can see, everything, because it's the correct colors that it would look like, it's much easier to decipher what would actually be. Now let's go back to this and let's go through how we make those colors. As you can see, because we extruded this, it becomes a simple body. And to work with that body, you're just going to want to right click and you have a ton of options. Change the material, you just want to go to physical material and it should pop up a bar right here. So once it pops up this bar, you can just select whatever material you want. For example, this would be 3D printed, so a plastic material would work nice. Just normally you would want to be a lot more considerate of what materials you use. But for now, this will work since we don't necessarily have a ideal plastic to make. Now that we have this, we know that we're going to want a yellow colored one. That's going to want to be yellow because that would be the color of the filament we'd be using. So in real life, the part would look yellow. So we're going to want to make it accurate. But we already know that we're going to be using this type of plastic and we don't want to change that just for appearance. So to do that, we'd go to the appearance section. It'll pop up this bar again, but now you can look for a specific type of color or any other material. You can just layer that onto it. That way you have the color you want at the same time as having the material you want. It allows for much more accurate depictions of what it's like. And so now we have this very, very basic connector. And so that's the basic of the sketch tool, that's the basics of the extrude tool and different things like that. We can also use many other things, like let's say we want a cone. What we could easily do is we could just make a triangle. And so let's say we want to revolve this. We're going to want to select the profile, which the profile is already selected. It's this. Then we're going to want to select the axis we revolve it on. And we get to select what amount of degrees we revolve it by. In this case, let's say we want to revolve it by 360 degrees. So we can type in 3. Say we wanted to revolve. And so now we have this small little cone of ours. You could use basic materials like that and basic just anything here to make any tool you want. Anything you want, really. A lot of the parts here we made using the sketch tool. We made the spacer using it, we made this using it. We just used some more advanced tools. For example, let's say we go into the modify. Let's say we don't like this being specific and we want to make it into 2. That way we can just use offset plane. We just want to make a plane on this end. We get to select where the plane goes. And the reason these planes are useful is because you can use them as cutting tools. For example, let's say we don't want body to a single body. Let's say we want it to be 2 different bodies and we want the top and the bottom split up. To do that, we can just say split body. And so we've selected the body we want to split. Now we just get to select the plane we want to split it by. And then it shows where it's going to split it. Let's say, okay, let's say we want it that way. Now we have 2 different bodies, these 2. That's one way you can just use one of these tools. Here, and let's just delete this. That's one way we could use one of these advanced tools to just thoroughly make more parts. So now that we have this, let's say we want to make it more like a dart. So let's extrude this. And so we don't know the exact amount we want to extrude it by, we just know it wants to reach. We can select this and it'll tell you the distance you want to extrude it by. Now we have a dart. Probably not an efficient dart, but we have one. And we made that through using the split tool. We made a cone, then split it up, and then we extruded the rest of it back to it. That way we have this odd shape. Now, let's say we want to just combine the body. Say we don't want to have this extrusion. And this is one of the uses of the timeline. Let's say we don't want this here. We can just go back and delete it. We no longer have it. Now, let's say we want to put this back together with this. We can just select this body. And here's one of the cool movement options. You can select the point to point. It allows you to select a certain point. Let's delete that one. It allows you to select a certain point that you want to move. And then it tells you where you can move it to. That way, we can just thoroughly connect it back together. Now, it's still two separate bodies, as you can see here. One way we can change that is by using the combine tool. We select the first body, we select the second body, we combine them again by pressing OK, and there you go. Now it's all one body. Now, these are ways we can just use all these tools to make many different things for changes. So beyond that, there's not much we use off of the very basic everyday tools. We use some things like the fillet tool where we might not want a sharp edge. We can change that by just saying we want to fillet it by a specific amount. That rounds the corner around it. Now, beyond this, we don't use many of these tools freely. We use some of them every once in a while, and they can be more advanced or more slow, but we can make things like this, even with the very basic necessities. Now, one of the big things I do want to talk about is the timeline. The big reason we have the timeline is because we can go in, we can see all the changes that we've made, just right off the top, right off the bat. And so let's say we don't want this change. We want to change it. We can just say that we know this extrude affects these. We can just delete this extrusion. And there we go. It's no longer there. We could also revert it by just pressing Ctrl Z. Now, let's say we don't want this extrusion, like we already said, and let's delete it. But one big thing is, now that it's gone, other than pressing Ctrl C to revert it or undo it the moment you do it, there isn't a way to add it back. So do not do this unless you know you're going to immediately revert it, or unless you know that you want to keep it that way permanently, or you're going to have to redo that specific task that you've already done. Now, one big thing that is with the timeline is when you have massive parts like these, there is a long timeline, and it can take a lot of processing power. Now, to prevent that, you can either disassemble the timeline by going into here and saying, do not capture design history. Right now we have that selected, so timeline, and then you can turn it back on. But one thing that we like to do to make sure it saves space is once we know we want this piece to stay the way it is, we don't want any changes to it, you can just go in and say, do not capture design history. Continue. That'll erase the timeline. But if we go back to capture design history, it'll turn the timeline back on, but it'll delete all the previous times. Now, the reason this is useful is we can go in and say that we no longer want to change anything. It's all good. We can finalize the timeline. Then we can start a new timeline, and that resets the CPU. It no longer takes as much CPU power to process what's going on. And that way we can have the timeline open without having a long list of thousands of times you've done stuff. For example, what we would do with this robot, because we have massive amounts of files inside of each other. Okay, so this is the basic necessities of what we have, what we're going to be doing. There is one last topic I want to cover before ending this video. That would be dragging and dropping different parts in, just incorporating different parts. So to do that, first we're going to need a saved file. And we're not going to want to save this here. Let's go out of this and select a new. Let's say 2022-2023 season, other Fusion tutorials, and let's say, there we go. Got our new one. It's just going to be called Untitled, because I am too lazy to title it. And so let's say we want to drop something. So we're going to want to click it, drag it in, and just drop it where it is. That way it'll open up this file right here. And now that it's incorporated, we can use it inside of our design to make sure that everything is perfectly correct. And that'll be all for this short tutorial on the basic necessities of what we do in Fusion.